Hello. So, has become a bit of a tradition now. Gonna be going over the latest LXD release, which has been tagged yesterday. It's LXD 4.9 and it comes with quite a few new features. The first kind of highlight is that we had a number of features be contributed by students at the University of Texas in Austin. So this release features at least 4 of them. One is ability of limit the total number of instances within a project. We also have the QEMU driver version being now exposed through the LXD server environment. We've got IOMMU groups as well that are now tied to, now recorded as part of every single PCI device in the resources API. And lastly, there's support for arbitrary user configuration keys directly on the in the LXD server config. Anyway, we'll be going through those in a bit more details next. The, I guess, highlight feature possibly for this release is the addition of mediated devices. So that's effectively graphics card, primarily I believe Intel and NVIDIA, supporting dividing your physical GPU into smaller chunks based on profiles. Each of those profiles can come with a maximum render resolution, some amount of memory, some amount of GPU power. That's somewhat readily available on recent Intel embedded graphics, as we will see here. And it's also what's used for GPU pass-through into things like cloud instances on the NVIDIA enterprise-grade card. So you won't be able to do that on a consumer-grade NVIDIA card, but you can on consumer-grade Intel cards. So first thing, let's look at a small addition we did to the resources output of LXD info. So if I list that and go down to GPU, we'll see here that on my particular laptop, I've got an Intel embedded graphics 620. And that comes with mediated devices support. So we can see here it's got 2 profiles. What that means here is it can either have 2 virtual machines getting a virtual GPU with a render resolution of 1024 by 768, or it can have just one VM pulling the bigger profile that gets you 1920 by 1200 rendering. It also has a different amount of graphical memory which may be used. So we can see that on the smaller profile, you've got like a guaranteed 64 meg with a 384 megs burst, whereas on the bigger one, you get 128 minimum 512 burst. So that's kind of what's supported on this particular system. If you look at this on a server grade NVIDIA card, like thinking Tesla T4, for example, you're going to be seeing a lot of profiles with a lot of different options. And it can sometimes get a bit tricky to actually figure out if I use this profile, then how many do I have left of the others? That's pretty dynamic. In this case, if I do use the big profile, I won't be able to use any of the small profiles anymore. That's kind of the way this stuff works. So to see how this actually works, I've got a virtual machine. It's called U1. We can see it's running on my laptop. And if we go in there and we look at the PCI output, I think it's PCI dash utils, or is it PCI utils without dash? Always kind of confused with those package names. Yeah, PCI utils, there we go. All right, so with that installed, let's look at the PCI devices. I think I need V instead of N. There we go. So that's the PCI device tree we've got on LXD. You see a lot of Vertio stuff. Important in this case is the GPU. So you can see that we've got the GPU attached to its own address, to its own bus. And that's a normal Vertio GPU that's attached to the VM. Now, that particular VM doesn't have anything interesting in its config. It's just a clean Ubuntu server. But we can make it a bit more interesting. So we're gonna shut it down. There we go. And then add a GPU to it. So let's just call it GPU. The type is GPU. It's got a custom GPU type now. That's a new key we've added for the support, which is mdev. So we're going to use that. And then we need to specify the profile we want. I don't actually have that in my scroll box. I'm just going to go and put it again from here. So going back to the GPU, let's use the big one. So that's the profile name. Put the profile here. And then you need to indicate what GPU it is on. You can do that with either like a card number or product ID or the PCI address. So in this case, we're going to be using PCI address. So that's effectively telling LXD, please create a new GPU using this profile, like a new vGPU using this profile on this card, and then attach it to the VM. All right, and let's start it back up. Give it a few seconds to boot, and then we'll look at how things look like. One maybe common misconception around vGPUs, while you do get a GPU inside the VM and you can use it for compute and for rendering, you don't actually get any kind of output on it. So you can't tie that to like a physical VGA port or what have you. The VM, anything that the VM renders on this GPU will just go nowhere. But you can pull that rendering buffer and then stream that or do a bunch of other options. But it's primarily used for compute. That's really the main use for that kind of stuff. So now if we go in there. Right. So we still see the LXD virtual GPU. This will always be there. LXD doesn't remove it because you add an external GPU. The virtual GPU is always there, and that's always the one that's also exposed through the console interface. Now, you do see we've got a new Intel Corporation's graphics, HD Graphics 620. So that's the slice of GPU I exposed to LXD. The way this kind of shows up is if you look at, I would have expected actually the RI nodes to be present. So I guess for some reason, because it says a server install, I probably don't actually have the relevant drivers loaded. But yeah, it's on the PCI bus. You can load drivers and you can use it for things like rendering, OpenCL type thing. You could use it to do hardware decoding and encoding, for example, for video streams. Or you can even use it, as says, to render things, but then you need an external solution to pull the render buffer and do something with it. One thing I don't remember is whether when we do this, if the number of profile exposed by the kernel changes. Yeah, it does. So because I just consumed one of the larger profile, we now see 0 available, and we see 0 available on the smaller one as well. Just for kicks, we could stop that VM. And look at the mdev profile on there and just change it for the smaller one of the two. Okay. And then start the VM back up. At which point I expect that we'll see we're not going to be able to do any more of the large one because it no longer fits, but we do have one available of the small ones. So I could have 2 VMs get that amount of resources that could then maybe use that for things like either compute or video encoding and decoding. So that's the first feature in that LXD 4.9 release. Well, first major feature. Then we've got a number of improvements around reporting on the server side. So one of them is that now if you do LXD info and you scroll down, you're gonna see on the driver side of things here, you've got both LXD and QEMU being reported with their versions. So that's just a bit different from before. We just had LXD reported, and QEMU version you never actually had exposed, so you never actually knew whether a given LXD support LXD server even had QEMU working. Now you do. So that was a tiny improvement, but it's quite nice. The other thing that we've made some changes on are the lifecycle events. So I think I showed that in a previous stream, but you can always do LXD monitor type lifecycle. And that only gets you events for some specific operations. So let's just launch a new 2004 container. So we see instance created. That was one event. Instance started. The instance has not started. If I snapshot this thing, we get an event for snapshot. If I rename the snapshot, we get an event for that. If I was to restore the snapshot, then we will similarly be getting an event for that, instance restored. If the instance is restarted, you will similarly get instance restarted. And then if the instance shuts down even from like within the instance, you get instance shutdown. If the instance is forcefully stopped, you're gonna get instance stopped instead. There we go. So that's kind of the normal events we had. Some new ones we've added now are around export. So if I do an export of that particular instance using LXD export, we should see once it's actually done making a tarball of this thing. There's a new instance backup created, I believe, that we're gonna see, followed by an instance backup deleted. The reason for that is that LXD export actually uses an internal API to create backups and retrieve backups. So it creates a backup, then it fetches the backup, and then it deletes the backup. That's effectively how that works. I should probably have used an Alpine container or done optimized export to make this slightly faster, but that's the general idea. Just gonna give it a few more seconds to complete, otherwise I'm gonna move on to something else and we'll get to see that particular event in a tiny bit. Yeah, just gonna let it do its thing. The other thing that was added around events are network related events. So now if I create a bridge called blah br0, we get a network created event. Same thing if I just rename it, we get renamed, and if I delete it, we get a network deleted event. So that's a new class of objects that are getting lifecycle events. I think we will eventually get full coverage with events for any object inside LXD. The goal of the lifecycle API is to eventually become like your go-to audit type API that you can then dump into an audit log. This is, well, we're still quite far away from that, but like some of the nice properties of the lifecycle API is that it's much more structured than our logging API, and it's also works cluster-wide, so that's quite useful. And you can even make it work either for a given project or for a set of projects. So that's really quite useful. Really wish that export would go a bit faster. I'm really tempted to just create a new container. Let's call it Alpine, because Alpine is like 5 megs large, so it's gonna not take any time at all to export and compress. There we go. So for Alpine, we can see there's actually a funny encoding issue here with the URL. I'm not sure exactly what's up with that. I'll actually just make a quick note to investigate later. So we see instance backup created for that thing. Then in between there, the backup would have been retrieved and then deleted. And now we see the Ubuntu container just did the same thing. It finally finished exporting. So we saw the backup created, it got downloaded and then deleted. In this case, we can see it took about 3 seconds to actually download it. All right, so that's for that feature. The other thing that I think has been like finally completed in this release is for a long time we've supported setting arbitrary config keys on instances, kind of like this. So now U1 is going to have a user.foo=bar key. User keys, you can set them to, you can set whatever key you want to whatever value you want. LXD doesn't care about those. They're not considered to be a object change, so we're not gonna like reload anything when you set them. And those keys are really meant to be used to store external metadata to some extent, whether it's like a deployment system or monitoring system or something. You can use those keys to store that. Over the past few releases, we've somewhat accidentally added support for them on a number of other things. For example, you can definitely set one on a network bridge. It's the same thing. And that just works. The one place where we couldn't do this before has been on the server itself. So now, same thing, I can do user.foo bar, and if I look at my server config, it's also storing that key now. So that makes it fully supported across the LXD API, and people can definitely start making use of that to store any kind of data they might need as part of the LXD API. All right. Next up is going to be a few changes to the resources API. So, actually there was, no, never mind. I was going to say there was another change we did around the resources API, which was the addition of mdev in Lexi info resources, but I actually showed that as I was hunting down those profiles earlier. So the rest of the changes on the resources API are around, well, let's start with PCI. So if we go look at PCI devices, we can now see a new field here, which is the IOMMU group. And we've got that key for every single one of the devices, and reports, it kind of looks like it increments in this case. That's because I actually do have some well-configured IOMMU in my laptop for some reason, but like you can see they're shared sometimes. Like in this case, we've got a bunch of devices that are all using the same lanes and effectively get the same IOMMU group. So my network card, the SM bus, the sound card are all kind of on the same address. So that's very useful when you want to do PCI pass-through to virtual machines, because it's kind of an all or nothing. Like you can pass an entire IOMMU group if the GPU you want to pass in happens to be shared with a USB controller. You're going to have to pass both, otherwise it just won't work. So that gives you that knowledge, and you can see whether your configuration is correct or not. If not, you might need to go change some stuff in your firmware. So that was the first addition to the resources API. The next one is around both disks and network interfaces. I can't show it, well, I can kind of show it on the, no, I can't actually show anything on the network interfaces, sorry about that. But on the disk side, I can. So on disks, we've added the PCI address, which was missing before. So in this case, it's an NVMe SSD, and we see the PCI address of that NVMe SSD. The other thing that was added is support is a new USB address field, which is used on USB devices, whether they're disks or network interfaces. And that gets you the bus and device numbers. So if you then, that lets you effectively match it with the USB device further down. So in this case, we know it's 27. And if we go down here, we can see bus address 1, device address 2, so that's not the right one. If we go down to bus address 2, device address 7, there we go. That's the device we want. So that gets us the ability to properly match the USB listing with the individual devices, just as was possible with the PCI address field before. And I thought there was one more change to the resources API. I'm just going through things quickly. That might actually be it for the resources API. Yeah, looks like it is. All right. So two other kind of minor changes that have happened is it's now possible within a project to not only limit the number of containers and virtual machines that you have, like we had before. We had a limits.containers and limits.virtualmachines key, but there's now also an extra limits.instances key. Like I could do, well, let's do something silly. That shouldn't work. So if I do limits instances 2 on the default project, it should tell me it's not possible because I've got 18 of those. Okay, fine. So now if I do 18, and if I try to launch another one, it should fail. Reached maximum number of instances in project. So that's that limit at play. What it lets you do that you couldn't do before is that now you can say this project can only have up to 5 instances, and of those 5 instances you can only have up to 2 virtual machines and up to 5 containers, at which point the user gets to choose how many of which they want, but you can set exact limits on virtual machines, containers, and the overall number of instances. Okay, next on the smaller features, it's now possible to use Z-standard as compression mechanism. So you would normally do this by setting the compression algorithm for all images to Z-standard, and then if you were to publish that A1 container, the resulting image, if we export it, image export this thing, we see it's now tar.zxt, so it is exported with Z-standard. So that's all fine. The same, just gonna undo this particular setting. The exact same thing can be done on backups, in which case you set backups compression algorithm instead. And you can also do it on a per publish basis as usual, using the -- compression option to publish. And for backups, the exact same -- compression option on export. Okay, so that's it for the non-oven related features. So now we're gonna look through a number of features that were added around oven virtual networking in LXD. There are 3 features, and I'm gonna go through all of them at once to some extent. One of them, the first one of them, is the oven ingress mode. Oven is a virtual network. It has a parent uplink network. You can configure routing addresses from that parent network onto instances on the virtual network. And the way it used to do that before was using an L2 proxy mechanism. So effectively that would mean Oven itself will respond to ARP packet or NDP packets on the parent, on that uplink network, and pretend that the Oven gateway itself held all the IPs it's responsible for. And that would cause the traffic to go into Oven, and then Oven would send it to the right spot. That works fine, but it's got some limitations. The way this is done inside Oven is that you need a record per IP address, not per subnet. So if you're using a wide subnet, say like a /24 on IPv6/64, it just destroys Oven pretty much. So for that reason, LXD has been checking how many IPs that would be and refusing to use very large set of IPs with that feature. So that new config key we've added, which is oven.ingress mode, now lets you set it to routed instead of L2 proxy. And in routed mode, Oven doesn't do anything. All it does is effectively it expects the upstream router to know to route those subnets or those addresses to the Oven IP address on the uplink network. Then you've got multiple options to do this. I mean, either you just do it manually. Every time you configure something, you go and modify your upstream router to route the right thing. That's one way of doing it. The other way of doing it is I wrote a small Go project called LXD BGP, which is a daemon that then exposes those Oven external routes, effectively, over BGP to either a level 3 top of the rack switch or to your router. Which then lets you automatically add those addresses. The other feature which was added, kind of related to that, is support for unicast on IPv4 and IPv6. So normally if you were to try to route the exact same address or exact same subnet to multiple instances, LXD would tell you, don't do that, I'm not gonna let you do it. Now you've got an option to say, actually, I know what I'm doing. I'm actually trying to advertise the exact same address multiple times. I'm doing unicast, my upstream network supports it. And if you set that key, then the check is bypassed. And I'll show you in a minute what that lets you do. And the last option is support for disabling DHCP and DHCP v6 on a per oven network basis. That can be used for deployments that either do not use IPv6 at all, that only use static IPv6 in this case, and want to just turn off the dynamic allocation. Or similarly on the IPv4 side, if you want to still retain basic IPv4 support for things like static addresses, but you don't want to run the DHCP side of things. So now you can turn it off. Now to show you how this stuff can be used. So that's my virtual version of my upcoming server setup that's going to be hosting things like the Linux Containers Forum, our CI main server, image publishing infrastructure, a whole bunch of other things. I'm kind of preparing that infrastructure. It's like 3 new machines plus a router at a new site with a new hosting provider. So the way I've set it up is I've got 3 identical machines. They are LXD clustered, so we can see this here. They are also Ceph clustered, so all the storage is backed by Ceph, and they each have the exact same storage configuration, which makes it all redundant. And lastly, they also all are using Oven for networking. And Oven is effectively backed by a like a core VLAN from the top of the rack switch. And I'm using that LXD BGP daemon on every single one of them, which then exposes all of the external routes from Oven on all 3 machines directly to the top of the rack switch that acts as the router for the subnet. What you see here at the bottom is the current view of the BGP tables on the top of the rack switch. So it received its default gateway from another BGP peer, that's the first and third record, and it received a number of routes from LXD BGP, that's all of the others. In this case, we can see 1000, 1001, 1002, 1003, so like those, if I can highlight them, that chunk here. And those line up with the network output I showed earlier. They line up with those 4 networks. Additionally, you're seeing 2 static, 2 like single addresses. So there's like a /32 v4 and a /128 v6. Those are unicast records. So if I look at my instance list, I've got 3 instances, DNS ES 01, 02, 03, which are running on the 3 different servers. And they're also running on the 3 different networks. On each of those networks, they have a external address v4, which is identical on all 3. And similarly, I've got an IPv6 as well, which is identical on all 3. So we can see that here. Now, what that lets you do is they truly believe they all have that IP, and they actually do, except that only one of them can really use it at a given time to go to a given address. But it's perfectly fine for actually responding to stuff. So what you see at the top is I'm pinging from my laptop the IPv4 and IPv6 address. By the way, there's no point in trying to ping that from wherever you are. That network is currently simulated here. It's going to be a couple of weeks before it's actually live in the new location. So they're pinging. We can see quite a pretty high frequency. And now let's see if we can figure out who's got what as far as traffic. Let's try to find the one that's handling. Well, this one seems to be getting nothing. So 01 is currently getting nothing. 02 is getting IPv4. And then that means that 03 is getting IPv6. Yep. Okay. So let's go in 02. And we're going to be seeing the IPv4 packets coming in. 02 is running on Langara. That's that other system I've got here. Now let's simulate that system going down. Part of the system going down will be the BGP daemon getting stopped. So that would effectively trigger this. Look at what's going on, both the traffic going on here and the ping going up here, like on the top left. So I stop the daemon. I'm no longer getting any pings onto the that server. But up here, it's still pinging perfectly fine. In fact, if I stop it and I look at it, you notice we didn't drop a single packet. And it's still pinging. It's just not pinging this one anymore. Let's see which one it's pinging. Nope. So it looks like everything is going on 0.3 right now. Both v6 and v4 are all headed to the same one. Yep. Okay. And now, say the machine was to come back online after its reboot. The container will start, the BGP daemon will start, the BGP daemon will monitor those lifecycle events to wait until the container is marked as started. Once it's marked as started, it will publish the routes again. That takes a little while to actually communicate with the top of the rack switch / BGP router. But once it's done, it's just took the traffic again and it's pinging. And again, same thing up here. If we look, we didn't drop a single packet. So that's what you can do with BGP and this integration with LXD and Oven networks. The other thing is that Oven itself is distributed. Its database is replicated on all 3 systems, and its outside port can migrate between machines as they go up and down. So that means if I need to take a machine down for maintenance, I can move the most critical containers that are not unicast. I can just move those to the other systems with a short downtime. The containers that are unicast, I don't really care about them. They can just go down with the machine. I can stop that machine. Any network traffic that was currently routed through it will just get routed through one of the others. The machine can be taken down, maintenance be performed, rebooted and stuff, come back online. We move back the few instances that were moved away before, start them back up, but any of the unicast services will not have seen a second of downtime. And the rest of the system I can restart that machine and not really impact any of the other 2. So that's really like fully redundant HA LXD with HA storage, compute, and network. And that's the end of the new features for this release. Like this particular demonstration, like obviously some of those features were kind of driven by me as I'm preparing this new setup. And I really wanted to give a good shot at how Oven support and really see how far we can take it. And I think that's pretty much as far as it gets. I've got like fully working IPv4 and IPv6 networks with unicast with very good throughput, getting like easily 10 gigabit across those networks. It's, yeah, quite looking forward to getting the rest of the hardware in and then moving over to that new infrastructure. And I hope that some of that will be quite useful to others as well. Just before we wrap, I saw there was one question in the chat, so I'm going to try and address that. The question is like whether there's any plan to support Ansible modules for LXD, like adding the functionality to create VMs and other new features. So we usually don't contribute to upstream projects like that so much. I know there are existing Ansible modules to both control the LXD config and also to use the LXD exec type commands rather than using SSH. So those exist. I'm actually playing with Ansible a bit as part of that setup, and I'll probably be contributing a few fixes here and there as I need them for myself. But otherwise, the LXD team is primarily Go and C developers. We're not that into Python. So it's probably best to reach out to the maintainers for those particular modules. But yes, like it feels like there's a lot that could be done there. Definitely adding VM support would be nice. The main kind of sticky point for me right now is project support. I definitely want good project and clustering support in those Ansible modules so that people can really use all of the LXD features. And yeah, that's it. If you've got any other questions around LXD and this LXD 4.9 release, just leave that in the comments. We'll keep an eye on that and respond. Or you can always go onto our forum and ask more questions there. The LXD 4.9 release will most likely be pushed to stable snap users on Monday or Tuesday next week. We are tracking down a few kind of last minute bugs that we want to have fixes cherry picked for prior to the release. But otherwise, that's pretty much it. actually, I'm just going to just show a couple more things. In that BGP I put down there, you can actually see the last time the route changed for that for those IPs. So you can see it was 4 minutes ago, whereas the rest has been pretty stable for over a day. So that's an interesting thing to also look at and see change. And for anyone who's kind of wondering, oh, like I also have Intel graphics. Can I use that MDev feature for my virtual machines? Yes, you can, but you do need to do some boot time configuration. So if I look at my kernel command line, zoom that a bit, you see that my laptop has IOMMU enabled. It's an Intel machine, obviously, so I've got IOMMU enabled and Intel IOMMU enabled. This is a requirement for any kind of PCI pass-through, so you need that anyway. And then you need to enable the Intel virtualization options, and you need to turn off GUAC. I don't remember what it stands for, but if it's on, it conflicts with GVT. So you need to do that. And then you need to load a set of kernel modules, I believe. I think I've got that in rc.log. Let me just go check. Yeah. So you need to load those 3 modules: KVMGT, VFIO IOMMU type 1, VFIO MDev. And when you load those, then your MDevs will show up in the Lexi info resources output, and then you can start using them with your virtual machines. If that doesn't work and you think it's an IOMMU issue, you can use resources API to get the IOMMU group of your different devices and see if any of the numbers are shared with something else. If they are, then that's your issue. You might need to look for, I don't know, a firmware update or firmware setting to change to make that work. And yeah, that's it. So if any questions, leave them here on YouTube or go on our forum to ask more questions. Again, LXD 4.9 will start hitting users early next week. And thank you for watching.